Hello class, welcome to 6.5, Solving Systems of Two Inequalities. Now before we get started with solving and graphing systems of inequalities, let's just quickly review how to just do some basic graphing. So the first case we'll look at here is slope-intercept form when we have the y equals mx plus b. So what we're looking at here is finding our y-intercept, which goes right there on the -4 on the y-axis. And then we're going to use our slope, which is rise over run. So this is saying down 1 over 3, down 1 over 3. And if we have to, that also means up 1, back 3, up 1, back 3. And then we get to draw a nice straighter line through those. When we look at standard form, for example 2, easiest way to graph these is finding our intercept. So if x equals 0, that means -2y equals 12 divided by -2, and y equals -6. So that's going to tell us 0, -6. That's our y-intercept. And the other thing we'd have to do is say y equals 0. So that's going to say, well, if 3x equals 12, I can divide by 3, x equals 4, and then we can go graph our x-intercept. And at that point, we can connect the two dots. A little bit better line there. And the third one, which we don't see too often, is point-slope form. But remember, that's going to be when our x and y become a point, and our m is still our slope. So if we look at x, that would be like saying -3. We look at our y, and that would be a +2. Again, remembering that the original equations were negatives. And this kind of works the same way, where if we know that one point is -3, 2, now it'll work the same way with our slope to say up 2 over 3, up 2 over 3, down 2, back 3. And then we have a nice line. All right, so we need to remember those three things to kind of help graph. The other thing we need to remember is in these other example, the next examples, is graphing the inequality. So this is where we are now looking for the solid or the dashed line, depending on what we have. Okay, so let's look at them. So remember, it always starts, no matter what the form starts with, it always starts with graphing. Use our slope, up 2 over 1, down 2, back 1, down 2, back 1. And then we need to determine, based off of this, that this is going to be a dashed line. We also need to figure out where to shade. So take that point right there, 0, 0. And that's going to be our test point. If we plug in 0 for y and 0 for x, which 2 times 0 is 0 less than 3? If that statement is true, we are going to shade the true side. Again, because that makes that whole side true, that whole side false. If we look at this next one, start at -1. Down 2 over 3, down 2 over 3, up 2, back 3, up 2, back 3. Now, first thing we're looking at here, solid line because it's equal to. And then again, if we test out the 0, 0 point, so is 0 greater than a -1? That one would also be true, which would make this side false. And remember, we are always shading the true side. Okay, so now we're ready to do a system. Okay, when we look at graphing a system, we first start by graphing both of our inequalities, but then what we need to do is we need to find where these two solutions overlap. So that would be our answer. So the first one here, we'll do this one in blue, which is going to be -2, up 3 over 1, up 3 over 1, down 3, back 1. And this one I'm going to do with a dashed line. Now I also want to make sure I test this out. So we're testing out that side. So if I plug in, is 0 less than -2? That's going to be false for this first one. So that is going to tell us that this side is true. And what we're going to do is just shade this side blue. Now, if you're doing it with your pencil, we want to do it nice and light because we still need to go back and do the second one, which the second one I'm going to do in red. So it starts by graphing it. So we start at 2. We're going to go down 1 over 2, down 1 over 2, and so forth, up 1, back 2, up 1, back 2. Now this one's going to get a solid line because it's equal. And again, we want to go back here to 0, 0, and we're going to test if 0 is true or false. So if I plug that in, is 0 greater than 2? Well, that is also false. So that means for the red one, we want to shade the true side, which is going to be above it. And if we shade here, that's the start. So we got both of them. And what this means here is when we go back, and I'm going to shade our solution in black here, when we look at this, we want the spots where the solutions are overlap. So when they overlap, this is where you can see red and blue all in this vicinity. So when we go through here and we start shading that area, that is going to be our solution. If we're going over here, we want to make sure that that is nice and dark, darker than the rest of the spots. And really, when we look through this, some people like to kind of maybe erase these other sections down here, the red and blue. But we really need to make sure, no matter what you do, this is our solution area. So basically, any of the answers in that spot, like our 5 5s, anything over here, we come over to like 5 5 up in that region, 4 3, 6 1, 6 2, 6 5. All of those numbers are going to be solutions to both equations. We get down here, it's only solutions to blue. We get up here, it's only solutions to red. We get over here, and it's solutions to neither. But right here, this whole region that we're shading extra dark, that is our solution area. Okay, so the same thing goes here. So we'll do this first one in red. So might have to just do a little side work, right? If we say x is equal to 0, that means -6y equals 6. Divide by -6, and y equals -1. So if we go 0, -1, that's our first point. If y equals 0, that means 2x is equal to 6. So if we divide by 2, x equals 3. So if we go over here to 3, 0, that's our 2 points. Equal sign means this is going to be solid line. And then, of course, we want to test our solution. So if we plug both these in, 0, 0, is 0 less than or equal to 6? Well, that is true. So again, we're going to kind of just like shade lightly here. And I'm going to switch colors to graph this blue one. Okay, now remember this one here is going to start with a point. This is our point slope form. So that means we can start at the x of 2, y is -2. So if we go up here to 2, -2, that starts down here. And now we have a slope of down 1 over 2, down 1 over 2, which means up 1, back 2, up 1, back 2. This one here looks like we're going to do a nice dashed line. Again, we want to test out that point 0, 0. Now this one here, as we go to plug in our 0, that's going to leave us with 2 less than -1/2 times -2, because if x is 0, it just kind of disappears. So we will have to just look at here and say, what's half of -2? Negative half of -2, which is going to be a +1. Is 2 less than 1? That is false. So that means we're going to shade underneath the blue. And if we want to look at where is our overlapping region, well, over here, this is where it's red and blue. Make sure we shade this section a little extra dark, because that will be our solution where both of those are true. Again, if we look up here, this would be the section where only red is true. This is where only blue is true. This is our solution area. That's where all of them are true. And then over here is where neither of them are true. So that's what we're going to look at as you practice these problems. Okay, so example 3. We'll do this one in red. Start at -2, up 1 over 3, up 1 over 3, down 1, back 3. This will be a solid line. If we test out our point, 0, 0, is 0 greater than or equal to -2? So that's going to make it true for our red. So we can shade above. If we're going to take a look here, make that one blue. So that's going to start at a +6. 1, 2, 3, 4, 5, 6. Down 3 over 2. Down 3 over 2. Down 3 over 2. This one is also solid. Test out our point. 0, 0. Is 0 less than or equal to 6? That is true. So that means we're shading underneath. Oh, didn't get to change my thing. But where do they overlap? Because this is where we really want to focus on. Right in this section, that is our double overlap. Make sure that this is way darker than the rest. Okay, so there we go. That is our solution area. Okay, the last ones over here, we now have 4 of them, okay? Usually we work with 2, but it is possible we work with more than them. So with that, y is greater than -4. Well, that means, let's go down to 1, 2, 3, -4. Y means horizontal. It's going to be dashed because it's not equal to. And greater than means above. Okay. Y is less than 3. We'll do this one in blue. So that means we're going to go up to 3. Again, going to be dashed. And less than 3 would be underneath. So now we shade underneath. So right now we know it's kind of already pinched in between those two values. All right, we still need to kind of go back in here, maybe find another color. I'm going to use green. And if we start at -6, that's here. Up 2 over 1, up 2 over 1, up 2 over 1. Okay, this is again going to be a dashed line up through. And then if we test out that point in the middle, so this one might require 0 greater than -6. That's true, so that means when we go above that line, we're kind of going up here. Now keep in mind, right, we already kind of know that this section up here is no good, this section down here is no good. So we're kind of narrowing ourselves down into that middle region. And we still need one more left before we can fully conclude this answer. So let's go with orange, and that would be +6, would be 4, 5, 6. And then we can't go up 2, so we're going to have to go down 2, back 1, down 2, back 1, and so forth. Once again, we're looking at a dashed line. And now we're saying less than, so let's go with 0. Is 0 less than 6? Well, that is also true. So that is going to have a shade underneath the orange. Now we got a lot of colors on here, but the key is, where do you have all of our colors? And think about this. We were underneath the blue. We were above this red one. We were kind of like above this green one and underneath this orange one. So that's going to tell us that we are stuck in this middle region here. Anything in those points is going to be our solution. Anything on the outside, as you see, we got colors kind of going everywhere, but that was the only section that had all 4 colors. Okay, those are the hardest case scenarios, but otherwise, you just got to really pay attention to where we go. If you're using a pencil, you know, just kind of keep them nice and light, kind of keep track of where they're shading, and we really want to zone in on where are all of our colors. All right, so let's take a look at some practice. All right, finish these problems up, and that way we can check them in class. All right, good luck. Have a great day.